video already we have discussed the potential energy of a system, and in this video that we have to discuss the electric potential due to a single point charge. If an isolated point charge is kept here, then what will be the potential electric potential due to a single point charge? So actually what happens here, the electric potential at a point is equal to the work done per unit test charge. We are bringing the charge Q in the last video already. We have in potential energy, whenever we are calculating the potential energy, one is the rest charge which is creating the electric field, and we are bringing the another charge in case of the electric potential energy. But in case of the electric potential at a point in the electric field, and that charge, that moving charge will be considered the test charge, unit positive test charge. So what happens here? The electric potential at a point is equal to the work done per unit test charge by an external agent in moving from reference point to that point P. If you want to calculate the electric potential at point P, this is the plus Q charge plus capital Q is here, and electric field is created by that plus Q, and we want to find out the electric potential at point P. So what will be the work done in bringing it from infinite to the point P? Here the reference point is considered as the infinite. From infinite to P, how much amount of work is done, and that work done per unit charge is to be considered the electric potential at point P. Suppose the test charge is taking from M to N through a distance dx. What will be the work done? So dW is the work done. dW is the work done in taking the test charge from M to N by moving through a distance dx. Then work done will be dW equal to F vector dot ds vector, that is equal to F minus F dx, because F is the electrostatic force is acting outward, and we are bringing in opposite to that of the electric force. Electric force, because it is plus Q charge, electric force is acting outward, and we are bringing from M to N opposite to that of the electric force. The angle is 180 degree. So F dot dx equal to F dx cos theta, cos 180. So this will be equal to minus F dx. And this is equal to minus, what is the electric force between the plus Q and the test charge here? The force equal to 1 upon 4 pi epsilon naught capital Q, and here already you have placed the unit test charge. Its magnitude is 1 unit, that is capital Q into 1 upon x square. The distance from Q to M equal to x, that is x square, and another dx is here, dx. This part is over. And what will be the total work done? The total work done in bringing the test charge from infinite to P, we have to take the integration. The total work done equal to minus 1 upon 4 pi epsilon naught Q upon x square dx, and integration we are taking it from infinite to P. P is at a distance of R, so infinite to R. So this will be equal to minus 1 upon 4 pi epsilon naught is taken out, and Q also taken out. The remaining is the integration of 1 by x square dx, and the limiting is the infinite to R, and this is equal to minus Q upon 4 pi epsilon naught, and the integration of 1 upon R square equal to minus 1 by x, and the limiting is from infinite to R. So this will be equal to that minus this minus makes it positive, so Q by 4 pi epsilon naught, and here you are getting 1 upon R minus 1 upon infinite. So this will be equal to 1 upon 4 pi epsilon naught Q upon R. This is the electric potential at point P. Hence Vp equal to electric potential at point P equal to 1 upon 4 pi epsilon naught Q upon R due to the single point charge. Because this Q charge, the source's Q is at rest, and we are getting the electric potential at this point P equal to Vp equal to 1 upon 4 pi epsilon naught Q upon R. And this also can be explained by using the potential energy techniques. What is the potential? The potential at point P, Vp equal to alternative method. This is the alternative one. Potential at point Vp equal to W upon Q naught, because already you have taken the Q naught is the test charge. So what is the W? W equal to change in potential energy, or change in potential energy is the negative of the work done. So that is change, that is U infinite minus UP equal to minus W, or what will be the UP minus U infinite equal to W. So W equal to UP minus U infinite upon Q naught. So what is the UP? UP equal to 1 upon 4 pi potential energy at point P. Potential energy at point P due to the any other charge, Q charge. If you are we are keeping the another charge having the values, having the quantities, that is Q naught. The potential energy will be 1 upon 4 pi epsilon naught Q naught upon R. And another Q naught is here, so Q naught cancel, and you are finding the potential energy 1 upon 4 pi epsilon naught Q by R. So in both the cases, you are finding the potential energy, but potential at a point P equal to 1 upon 4 pi epsilon naught Q upon R. If you talk about the potential energy at a point, whenever you talk about the potential energy at a point, at the same time we have to consider the two charges. One is the plus Q source charge, and another will be the charge having certain value. In that case, the formula will be 1 upon 4 pi epsilon naught Q by Q1 Q2 upon R. But whenever the only the potential at that point, and you must have to consider that is the test charge having the unit positive test charge, and the formula is equal to 1 upon 4 pi epsilon W Q upon R. So overall, we are getting the ideas, the electric potential at a point and electric potential energy due to a system of two charges. If we consider the electric potential energy of a system of charges having many number of charges, three charges are there. If Q1, Q2, Q3, three charges are in a system, what will be the potential energy of the system? In that cases, we have to pair the charges. Q1, Q2, Q3, the Q1, Q2, that should be paired. Q1, Q3, that should be paired. Q2, Q3, that should be paired. And what is the total electric potential energy of the system? At the same time, you have to find out the total potential energy, that is U equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R12 plus 1 upon 4 pi epsilon naught Q1 Q3 upon R13 plus 1 upon 4 pi epsilon Q1 Q3 upon R13. In this manner, you can calculate the potential energy of a system of charges, and we can calculate the potential energy of a system of two charges, three charges, four charges, and n number of charges. In that manner, if you talk about the potential at a point, only the potential at a point, only the source charge will be here, and the other charge will be the test unit positive test charge. That's value is equal to 1. This is all about your electric potential at a point and electric potential energy of a system of charges. And after some time, I will send you some assignment regarding that electric potential energy and electric potential. Thank you.